Hello everyone. Now in exercise 14 we will speak about stateful deployment and the difference between stateful deployment and standard deployment. So the exercise says the SkyTrade Corporation backend engineering team is deploying a Redis cache cluster that requires stable and network identities and ordered pod deployments. Stable network identities means DNS, now DNS change. And ordered pod, so the pod will be deployed always in order, not random. For the real-time stock price streaming services. So in the SkyTrade streaming services, complex the following: create a headless service named Redis headless with cluster IP none. So there will be no IP on port 637 and selector API Redis cache. Okay, all and so I already created these services, so it has no IP. It is cluster IP service with no IP. This is headless uh, service. Why we create it? We create it in case of stateful containers. So stateful containers are designed for applications that require stable and unique network identifier. No change. Stable persistent storage. Also, each pod has its storage and it's bounded to it. And an ordered graceful deployment and scaling. So if I deploy the pods, they will be in orders: pod 1, pod 2, pod 3. And when I stop them, I stopped them in the inverse. I stop pod 3, pod 2, pod 1. So unlike deployment stateful, maintain sticky identifier. So if I create pod 1, pod 2, pod 3, they will be always named pod 1, pod 2, pod 3 in my cluster. Even I change, I restart the host, I migrate, they will not change. But in deployment, we know that the naming of the pods are random, and the cluster can change the name and and the related DNS. So if I have this application called Redis cache, my pods will name it Redis cache 0, Redis cache 1, 2, 3. So each pod will get its stable DNS name. The DNS will be Redis cache 0, Redis cache 1, 2, 3 with the cluster naming, of course, like this. Redis cache and Redis deployment. This is deployment. This is the cluster, the namespace, and this is this SVC, the cluster. This is the local. So this is the first pod, the second pod, etc. Now to create the cluster is easy for service. So just add it's standard service creation. So just add the now cluster IP to it. SVC. Now cluster IP dot YAML, and this is service name namespace. Now cluster IP and the ports. Of course, the selector, because we will select the reader cache deployment. Now we will create the deployment. So vi deployment stateful. So in my deployment stateful, it says create stateful name it. It's deployment. Don't. It's the same. Redis cache with 3 replica using image. The stateful must use the header service Redis, of course. Its service as service. Its service name. The pod should be label and include the volume template. This volume template is new, and we will speak about how we can create volume template inside the inside deployment. We then create a volume or a volume claim. So we will create the the first part of this deployment. So it is stateful set, and it is name and this namespace. So the spec service name. So I am saying to this deployment, this is your service name, and the selector is the pod name. Also the metadata is the default app labels. This is for labeling. And all others are standard container configuration, the name of the container, the image, and the port, and also the volume. So we have a volume mount that is generally standard volume to my local data. Now, the most important part is the volume claim template. So create volume name template that will create a claim for you for our deployment. So it's like the volume command in any pod, but with some differentiation. Here we don't need to create the PVC. The volume will, the template will create for us the PVC and the volume, and we will check. So okay, the service name template. Okay, templates should be here. Template specs container. Now the volume claim template. So we create a volume claim template with this name, and this name will be used here in the volume mount. It's similar to the volume command in standard configuration, but here it will create the PVC here, and it will create PVC with access mode, read write once, and the request. It means that it's like we create PVC and we call it inside this container. So the volume claim template creates PVC name redis template and a volume. The result is a volume with 1 giga. This volume will be mounted here in this mount path. And of course, the default is file system. So here is will be a file system storage class, the default storage class. There is no storage class here, but in this case, we'll use the default storage class in our cluster. So we'll create a volume for each one. So now I can create the stateful deploy. Stateful deploy. After creating, we will see that the pods are created, 3 pods, and the naming is taking the name 012 and has the cluster IP. It's stateful set. It's 300. You can see that it creates automatically the PV, the volume. Are three volumes are created with this storage template that we already used of 1 giga and creates the PVC inside the okay 3 PVCs each for 1 volume and mounted on this PV in the default storage class, this one. This will here, this one. We can see that it's in the retain normally. It's file system, okay. And okay, now come back to the exercise. We can go more detail about this stateful configuration. So repeat that the name, if I restart the pods, the name will be changed, will not be changed like in standard configuration. So, okay. These are. Suppose that I will okay, hold on. Restart. Suppose I will restart this deployment. This start stateful. Stateful deployment. This one. Okay, I will check the pods. Still test with the order and with the same name. Okay, okay. Now go to the next exercise, monitoring. Describe service. And my service is single stack without DNS. Okay. So the very important that stateful deployment will always keep the order and the naming, and DNS is always fixed. And in case of the question mentioned that stable network DNS, so we have to use this stateful, not deployment. Normally you can ping it. I don't know if you can get it is, you know, host. Okay, I have to log inside one pod. Oh, run. I will come on it. I will go inside one pod and check the DNS. And shell. Okay. My NS lookup. So this is stable. Let's look up. Host. Generally, we have to get this because we have several web. Okay. Okay. Next exercise. Uh, the SRA team, Service Runtime Engineer team at SkyTrade Corp is deploying cluster-wide monitoring solution that needs reads only access to various resources across all the namespaces. So it needs some cluster airbag access with limited roles on all namespace. So the monitoring agent will run in a dedicated namespace and need to scrap metrics from pods, nodes, and service through all the cluster. So this is something that we usually like. We provide read-only access for one user to monitor all the cluster. So go to the cluster side, create a namespace. Okay, create. Okay. Now create service account. Service account. It says monitoring as a in this namespace. Okay. Now create role binding role. Create service account. Now create cluster account. Cluster role. Okay. My age. Oh, this is different from create role. Create a role is for namespace, but cluster role is for cluster wide role. Cluster role. My ash. Let me see. So cluster role name. Cluster role name. Okay. Create cluster node reader. Cluster role reader. Okay. This is the permission, and this is get all watch. Get all watch. Get list watch. On this resource, okay, pods, nodes, endpoints, namespace, and events. Okay, this is cluster role. We repeat, is not namespace role, is cluster role. Nodes. Oh my god. Okay, nodes, services, and pods. Pods, nodes, services, endpoints, namespace, and events. Okay, we can see that. Okay, describe cluster roles. Okay, can see. Okay, this is the event, this is the resource, and this is the permission. Now we can create role binding. Create all binding. Okay, between this role, cluster role, and the service account. Okay, the name of the role binding. More hyphen cluster role name. Cluster role is name is this. Okay, cluster monitoring reader, and the service account that we have already created in previous setup steps. Okay, so monitoring as a namespace. We have to respect the naming. So namespace concaten with the service name. So create a role binding cluster with cluster role binding and namespace. Okay, because I already created. Now we have to test. If we want to test, we have some useful tools to test the access. So I am using this. Keep control authentication. Can I use? Can I? After I type the the name, okay. Can I can I list pods? No. Yes, me, because it's speaking about the admin. But if I will provide the user, okay, yes, can I list yours? Yes, yes, if because he can list pods, he can list events, events, sorry, yes, but I can't, for example, modify. I have only get the monitoring user access has only list I can modify. Let's see, modify. No, modify or delayed. Can I delayed? Create. No, cannot create. Cannot pods, for example. Pods and anyway, anything. It cannot create any. It can just deployment, for example, deployment. No, he has only read only access list watch. It can watch. No, deployments are not included. So I think yes. Endpoints namespace. You can watch services, for example. Services. Yes. Okay. Uh, and that's finished this exercise. So uh, the role and role binding scoped to a single namespace. Cluster role and cluster role binding. So scope are cluster-wide scope. Works across all namespace. So when we create, we have to make difference between role binding, role binding, and that is all only for namespaces, and cluster role binding, that is all it is for administrator purpose and monitoring everything. Now we finished this exercise and we will go to next series of exercises, and I hope you enjoy these labs, practices, and demonstration for Kubernetes cluster and DevOps tools. Thank you.